Good afternoon, friends. Today we'll discuss about dropper design, INSPAN dropper design. There are so many types of droppers, but we'll discuss about the INSPAN dropper design because it needs calculation to find out its length. Otherwise, the profile of overhead equipment conductors will not be the proper. But before starting the dropper design, again hear some music. Friends, today we will discuss about the INSPAN dropper. What is dropper? In regulated OHE, what catenary and contact wire is running as conventional OHE in single phase 25 kV system, there we need this dropper. But what is the function of this INSPAN dropper? Our contactor is approximately weight is 0.9 kg per meter, and if you increase the span, you know our span is varying from 27 to 72. But due to this huge weight, though contactor has been given 1000 kg tension both end, but due to its weight, it will sag enough to entangle pantograph, loco pantograph with contact wire. So to reduce this sag, it is around 500 mm or 600 mm if you don't fix the INSPAN dropper. So what we are doing, we are keeping the contactor almost horizontal, but it is not horizontal. Somewhere it is 100 mm in the mid span sag, and somewhere it is 50. Previously it was 50. Nowadays it is 100 mm in the middle of the span, and the sag of the contact wire is transferred to the catenary wire with the help of these droppers. So catenary has taken the sag, so catenary is having an elliptical shape, but contact is almost horizontal. So today we will show how to calculate it, but in the field it is not possible to calculate it and fix. But if we keep ready the droppers according to the calculation earlier, then you can fix it in the site. Actually, dropper mainly has been prepared in the workshop. Various type of sizes are there, and fix it according to the requirement in the site. The number of span is also varying. Maximum droppers number is 9 for 72 meter span, and then it will vary according to its span. It will reduce. I will show you how to calculate the number of droppers, INSPAN droppers in the span. Let's start. Friends, in the figure we can see that when there is no contact wire, catenary wire, then the pre-sag will be around 600 mm if it is 70 mm span due to the weight of the contact wire. But if you provide droppers wire and catenary wire, then you can reduce it up to 100 mm. Nowadays for high speed train it is 100 mm pre-sag. So this is the system of the dropper. Our maximum span is 72 when the span is divided by 9 stands some number, not a fraction, then the first two droppers can be spaced as 2.25 and 6.75. If you add these two quantity, it will become 9. So both sides 9, 9, all will be divided by 9. But if it is, we know all the spans are divisible by 4.5. If it is not divided by 9 but divisible by 4.5, then all the first span will be 2.25 for a dropper and all other droppers will be 9 meter. So a dropper both sides of the mast will be 2.25, then all will be 9 meter spacing. So easily you can find it out how to design the dropper spacing. But the problem is dropper length, as it is a semicircle of shape of the catenary wire, so it is somewhat difficult. Dropper length is slowly reducing up to the mid, and then again it is raising. Next we will discuss how to find out the length of the dropper. If you calculate it and can prepare it in the workshop and bring it to the site, then you can provide it. But in field they are doing shortcut system, so accurate profile cannot be achieved. Try to prepare the dropper earlier and send it to the site so that profile can be adjusted accurately. An example has been given just before the 72 meter span. If it is 67.5 meter span, it is divisible by 4.5 but not by 9. So the first spacing will be 2.5, then 999, then last a dropper will be also 2.25. So this is the system. You divide it by 4.5, it is divisible but not by 9. So you provide the first a dropper 2.25 spacing, and the next 6.75 is not required here. But when it is divisible by 9, then you need 2.25 and 6.75 both. Okay, thank you friend.